The law of sines can also be used to find missing angles. And just as a reminder from my previous video about finding sides, the law of sines is used when you're not working with a right triangle. If you had a right triangle, you'd want to use SOHCAHTOA. The sine is opposite over hypotenuse, cosine's adjacent over hypotenuse, tangent is opposite over adjacent. You'd want to use those. Those are maybe not easier, but those are what you would want to use for a right triangle. So law of sines is useful when the triangle is just any kind of non-right triangle. So let's do an example. So you can see from our earlier work with law of sines that the law of sines can be invoked here because I have an angle and the side that is across from it. That's the key to knowing you're going to use law of sines, is this relationship between an angle and the side across from it, because it helps us establish an initial proportion where we say the sine of 32 degrees over 9 will be equal to any other pair angle side, across from each other pairing. So that's really the key here, is establishing that. If that can't be established, we're going to invoke the law of cosines. Okay. So the angle we're looking for, of course, is x, so it's going to be the sine of x degrees over 11. Okay, so let's do what we did in our previous video and start by multiplying, cross-multiplying to get rid of the fractions. And then, of course, I'm solving for x, so I'm going to actually divide both sides by 9. I guess I could have just multiplied the 11 over. Now, I've got 11 over 9, sine of 32 degrees, equals the sine of x degrees. Now, to get rid of a sine function, we use an inverse sine function. And that's on your calculator. I'll show you how to type that in. But essentially, then, we're going to take the inverse sine of our entire thing, and that's going to be equal to x. Let's type that in. All right, so you have to hit the second button and then sine. So you have inverse sine, and then I'm going to type in the rest, the 11 divided by 9 times the sine of 32, and hit enter. And there we are, 40.37, depending on how many decimals you want to round to, but 40.4 degrees. Let's do another example. Once again, let's just establish the fact that law of sines is the proper thing to use here. It's a not right triangle, and we have this pair of an angle and the side across from it, so that establishes our initial proportion. And this will be equal to the sine of x over 14. Now, maybe in this case I should just multiply the 14 over, no sense in cross multiplying as we saw in the previous example. So then we have 14 over 22 sine of 100 equals the sine of x degrees. We're going to take the inverse sine of both sides, like that. So we'll type this in. Once again, do second sine to get the inverse. 14 over 22 times the sine of 100. And there it is, 38.8 degrees. So this is the way that we use the law of sines to solve for a missing angle. As soon as we can establish that proportion of an angle on the side, or the sine of an angle on the side across from it, we're off and running. If this video helped you, please like and subscribe for more geometry content.